Yes, thank you very much. I would like to start my talk with introducing the general topic, which is language mapping and how is it motivated. In the neurosurgical resection of brain tumors within the central region, it is essential to identify language-related cortex. And the gold standard so far is the intraoperative, which means the invasive method of direct cortex stimulation. To induce a transient focal inhibition of language processing in a speech production task. TMS language mapping, TMS enables to induce likewise a virtual lesion invasively. And TMS language mapping is therefore commonly applied in clinical research, such as pre-surgical planning in case of brain tumors. And mostly an object naming paradigm is used. And the session is videotaped for later analysis of qualitative language errors. Neuronavigation helps to align the call precisely over predefined targets. In a previous study aiming at detailed language mapping of Broca's region with a high density of target sites, we found a clear focus of TMS susceptibility overlapping with the dorsal area 44. However, the qualitative evaluation of language errors, or as we did here, the clustering of error severity and frequency, does not allow any conclusion, or does hardly allow a conclusion about the specific level of language processing in Broca's region. From functional imaging data, we know that semantic, syntactic, and phonological processing are represented in an anterior to posterior manner within the inferior frontal gyrus. And complementary TMS, numerous TMS studies have focused on semantic and phonological processing by targeting anterior and posterior sites, respectively. And in our study, to specifically address or investigate phonological processing and to obtain objective data, we introduced reaction time measurements in language mapping, with phonological picture-word interference. And in the phonological, or in the picture-word interference paradigm, related destructors or phonologically related destructors lead to a facilitation or the acceleration of naming responses as compared to unrelated destructors. And this effect is called phonological priming. And we concluded from this, or hypothesized, that the inhibitory effect of TMS on language processing could reduce this cognitive effect. And secondly, that this reduction of phonological priming occurs only at this stimulation site or at this anatomical area which is involved in phonological processing. This is the setting of our experiment and the arrangement of the technical equipment prior to stimulation. And we used a cross-model picture-word interference paradigm, which means that the target picture is visually presented and the destructor noun is acoustically presented via the speakers. This is a paradigm. Based on 90 target and 90 destructor nouns, we created 6 mapping blocks consisting of 30 target destructor pairs for 30 stimulation target each. And it's important to mention here that each related destructor, like here the cat and the card, was required to be presented, or each related and unrelated, like related and unrelated here, like here the cat with a tile, was required to be presented at the same anatomical position, at the same stimulation target in 2 out of the 6 mapping blocks. Yes, in 12 healthy native German speakers, we defined the stimulation target array consisting of that 30 stimulation sites covering the whole Broca's region. And the target array was systematically arranged according to macroanatomical landmarks. As commonly used in TMS language mapping, we applied 5 Hz stimulation, a repetitive TMS of 5 Hz stimulation with 5 pulses simultaneously with the onset of picture presentation. And we conducted 2 sessions, one active TMS session in which we used a stimulation intensity, the language inhibition threshold. And the sham TMS session served as control baseline. And yes, to later assign the TMS simulation sites to anatomical structures at the group level, we generated 30 TMS-based volumes of interest from the stimulation markers, which were recorded during stimulation by the neuronavigation system. And then we normalized them to the MNI template. Yeah, in the analysis of naming latencies, both the audio track of the speakers and the audio track of the microphone is visualized to identify the onset of the auditory cue, which preceded the onset of the picture presentation and TMS by 500 milliseconds, and the onset of the first phonetic output. And this allowed to identify naming latencies on a millisecond scale, irrespective of all the TMS noise. So we could not use a voice key. Yes, prior to statistical analysis, we subtracted unspecific TMS effect, unspecific effect of active TMS by calculating the difference active TMS minus sham baseline per participant and separately for unrelated and related destructor pairs. In the repeated measures ANOVA, with 2 factors phonological relation, cytoarchitectonic area, we found a significant interaction. And it's, I need to mention here that for each stimulation target was classified according to the factor level 44 and 45, according to the largest overlap with the area 44 or 45. Yeah, in the analysis of simple main effects, we found only the difference area 44 versus area 45 to be significant for the related destructor pairs. But we were interested in phonological priming, which means that we need to mention the difference unrelated minus related latencies or target destructor pairs. And here, positive peaks indicate the facilitation, the cognitive priming effect, and negative peaks indicate the reduction of this cognitive effect. And to confirm the anatomical specificity we found already in the ANOVA, we calculated the specific directional hypothesis of reduced phonological priming in area 44, which you can see here with the negative peaks. Yes, this is the illustration of the center of mass of our TMS-based volumes of interest with related color codes to the icicle chart as I showed before. Yeah, so phonological reduction we found in area 44. Yes, to summarize our findings, we found the specific inhibitory effect of TMS in phonological priming, in area 44. And the sustained facilitation we found in area 45 may rather indicate an unspecific effect of area for of active TMS. Sorry, and it's maybe due to it reflects an intentional increase due to pain or discomfort during active TMS. And for the first time, we introduced reaction time measurements in TMS language mapping. With this, we achieved objectivity in data evaluation by using reaction times as a as a quantitative dependent variable. And by doing this, we addressed and manipulated, addressed the phonologic, specifically the phonologically the level of phonological processing. As such, in clinical applications, reaction time measurements could complement qualitative language evaluation. And to have an outlook, future studies will help to create a comprehensive mapping of Broca's region, since we're working actually on paradigms for semantic and syntactic processing. Yes, with this I would like to thank for your attention and like to thank my small team and welcome you to my poster. Thank you very much.
Would you have any questions for Katrin?